The trigonometry is kind of every day. You know, when you figure out where the dimensions that a building or room might have, whether it's in plan or in its height, because there are, you know, 3 dimensions in architecture.
I think anytime you draw a sloped roof, you have to start to incorporate trigonometry. So if you have a building and you say it's X feet wide, and let's say you have a height limitation for the building, you start to define some variables and you can figure out what your roof pitch is going to be. And then as a designer, if you want to sort of take that step, we say, well, what do we want it to look like? And how is that pitch going to impact that? And it's this sort of balance between the limiting factors and the design intent. And we have to use trigonometry to come up with a solution that's going to resolve all of those things that the project has to respond to.
A great way to engage students in STEM disciplines and, you know, the very technical parts of it is by starting with a design problem. So you can take a really simple problem like a house or a picnic shelter or something like that, and start with conceptual ideas. What do you want it to look like? What do you want it to do? And then you start to talk about how big is it, you know, and how do we measure that? So you can start with their own bedroom or a dorm room or whatever, and they measure it, they draw it, use scale. The idea of scale is really important. So how do I take something that's this big but draw it on a piece of paper that's this big? So that involves some math and figuring out scales and then using those tools that they may not normally use. So one way is by measuring your arm length, your foot so you could walk off a space, or your hand so that you know how many inches is this, and then incorporate that into scale. And then when we get to the design problem, we try to use, triangulation, which incorporates trig, sines, cosines, tangents, etc., circles. You've got to use all of that. Well, one very common element of buildings are roofs, and very many of them are sloped, right? So you have a bunch of things to consider in a sloped roof. So we have a pitch like this. This one looks like this is a gable roof. This is a shed roof when it just has one slope, and then there are all kinds of combinations of those. But if you just take a simple gable or a shed roof, one is it's in an angle. We have to figure out what this angle should be given the building that we have. So there are several factors to consider. How do we figure out what exact angle we want on that roof? Well, we know how wide the building is, we know how long it is, we know those dimensions, and we know then we can figure out, so we've got, that tells us this piece right here. And then we tilt the roof like this. Well, how high do we make this piece right here? So we've got to figure that out. If we want head height, how far we want head height, it might only be to here, so that we can create a room underneath. We need to calculate this. We need to know how much head height we need. So then we calculate that, then we have to know this length, this height, and then from that, using trig, we can calculate the diagonal. And then we know about how much roofing material that would be.